this week we're going to be exploring a side of mathematics called set theory. A set theory, it's hard to describe it without using the word in the definition itself, but it is an exploration of sets. And with that, the sets can be numbers, but it can also be like characters, words, things like that. And what we'll do is kind of use that to describe sets. We'll talk about some notation that comes up. And then as we talk about how sets can work together or how we could see them with Venn diagrams, this is really laying a foundation for when we get to probability. There are some rules we're going to see in these videos coming up here that'll carry through to next week when we talk about probability. So, some definitions and notation that we'll need is, first of all, a set. So a set is a collection of objects. Again, it could be numbers, it could be words, it could be pictures. Some notation that we're going to see is the brackets that we use for sets. We use these specific kind of curly brackets to collect the information that's in a set. And then what we'll do is we list those values out and we just separate by commas. Notice a word that comes up in the definition there is distinct. That just means that, like, if something could repeat, like say we have a basket of fruit. I have apples, oranges, and bananas. Even if I have 5 oranges, in terms of a set, I would only write it once. I would just write the words, I have apples, no matter how many there are, oranges, and bananas. But in terms of bringing through the number of those values, that we get into with the last video that we look at in this section with cardinality. But in terms of the set of what's represented in that basket of fruit that I have, that would be the set notation that we would use. Elements are the objects that are part of the set. So with the set up above there, apple is an element, orange is an element, banana is an element. So it's each of the pieces that are part of your group. So let's say I wanted to create a set for the outcomes of rolling a die. Just in case you're not familiar with this, die, that's the singular form of dice. That'll come up a bit when we get to probability. Typically, when we talk about rolling a die, it has 6 sides, and then we see a number come up. So in terms of the set of outcomes, on my set notation, we could see a 1, a 2, a 3, a 4, a 5, or a 6. So that would be my set for the outcomes from rolling a die. Some notation. We have this symbol here, and it's just read as is an element of. So let's say I grabbed from up above in that example there, the number 2. Something I left out up above here in describing sets is often we might choose a letter to represent the set. So if the apple, oranges, and bananas is representing a basket of fruit, maybe I'll choose a letter like B to represent basket, and that would be my letter there. And rolling a die, maybe that'll be my set A. So I'm getting to this with using this notation for is an element of, so that we have this letter so we can refer to the set without writing out all of the elements that are part of it. So if I want to describe 2 being this element of a set that's coming from rolling a die, what I would write is set, and then this notation for is an element of, and then my set A is there. I could also write, like with the basket of fruit, orange is an element of that set up above, B. If a set is empty, we use this symbol here to show an empty set. It's hard to kind of describe that here, but when we get to a section, I'll be sure to bring this up in the next video when we talk about like looking at where 2 sets intersect with each other. Like, actually, not too bad to talk about here. If I try to think about the overlap of set A and B, like where do those 2 things overlap? Well, nowhere. One's fruit and one's numbers. So if I think about, and I will definitely talk about this notation in the next, but we talk about like where's this intersection of these 2 sets? Where do A and B overlap? Well, if I think about the set of them overlapping, there's nothing in there. So we would just say it's an empty set. Or it's like drawing two brackets that don't have anything in between because the set's empty. Subsets, where we can talk about one set being part of another set. We have these two forms of notation for subset, and then there's proper subset. The main thing is that to be a subset, you see all of the elements in this larger set, and then if it's a proper subset, it's just they can't be identical. Like the notation you're seeing come up here is kind of like this less than or equal to versus less than that we see with inequalities. With a subset, we can have equality, meaning the subset could be exactly the same as the larger set. With a proper subset, it can't be that. So it can't be exactly the same, it has to have a smaller number of elements. So with that, if I have the set A here, and say I create a set B, well, let's say B happens to be exactly the same. Then what I would do is if I wanted to show that B is a subset of A, I would say B is a subset of A, but since they're exactly the same, we'd have to have that line underneath to show that it's actually the same set. Whereas if I had a set C that was a subset of A and a proper subset, it would have the elements of A, but not all of them. It can't be an exact copy. So then I would have C is a proper subset of A. And then our last notation that we're going to talk about is the universal set. This can also be referred to as sample space. And it's just everything. All of the elements that are in what we're looking at. So, for example, if we wanted to find the universal set of whole numbers between 2 and 8 inclusively, and that wording inclusively just means including. So when it says between 2 and 8, and then inclusively, it means that we're going to include 2 and 8 in that group. So we'd use U, and in terms of what's defined as is a subset, a set of 2 through 8. So 2, 3, 4, 5, 6, 7, 8. So that becomes our universal set, and then we could look at subsets of that or whatever we need to do. So in the next video, what we're going to do is talk more about relationships between sets.